In this module I want to talk about momentum. Now, the greater the mass of an object, the more the momentum will be. It's harder to stop a large tractor trailer than it is to stop a small compact car. Freight trains take much longer to stop than a short passenger train. Why? Because they've got more momentum. They've got more momentum. Momentum has a direction as well as a magnitude. In other words, it's a vector. Momentum has a direction as well as a magnitude. Quantities that have both magnitude and direction are called vector quantities. So don't forget direction as well. Now, the momentum of a particle is traditionally represented by the letter P. This is the formula to determine momentum. P equals m times v, where P, momentum, which is in kilograms per meter second, equals m, mass in kilograms, v, velocity, which is meters a second. That's why momentum is in kilograms per meters a second. Now, being a vector, momentum has magnitude and direction. For example, a model aeroplane of 1 kilogram travelling due north at 1 meters a second in a straight and level flight has a momentum of 1 kilogram per meter second due north measured from the ground. Do you understand? Model plane travelling north, 1 kilogram, 1 meters a second. Its momentum is 1 kilogram meters a second due north. Now, if no external forces act on a system, that's ignoring friction, then the total momentum of the system is unchanged. And this is the principle of the Newton's cradle. As you can see here, this is the Newton's cradle. This thing just keeps going. Now, this thing keeps going. Also, this principle is the same in a game of pool. If you play pool, I'm good at pool, I love pool. Playing pool, momentum is conserved. That is, if one ball stops dead after the collision, the other ball will continue away with all the momentum. Now, if the moving ball continues or is deflected, then both balls will carry a portion of the momentum. So if you hit a ball with a pool ball and the ball stops dead, all your momentum's transferred to that other ball. Whereas, like I say, if you hit it and both balls keep moving, then both of those balls will have maybe half the momentum, of the ball. Look at this example here. If two balls are approaching each other, one weighs 3 kilos and is travelling at 3 meters a second, and the other weighs 1 kilo and is travelling at 2 meters a second, when they collide, the second ball is travelling away at 1.5 meters a second. How fast will the first ball be moving, and in which direction? Well, let's use the laws of momentum. Okay? Laws of momentum. First of all, we need to determine the initial momentum of the system. Well, we've got 3 times 3, 1 point, minus 2 times 1. So one's got 3 times 3 and one's got 2 times 1. Now, I've taken the momentum of the second ball because it's acting opposite to the first one, giving a momentum of 7. So that would give a momentum of 7, power of 7, to the right. So do you understand? We've got a momentum of 9 to the right and 2 to the left. After the collision, it's got to add up to 7 to the right. Now, the final momentum must equal the same, and therefore 3 times v minus 1.5 times 1, because we said it's 1.5, equals 7. Therefore, 3 times v is 8.5. Therefore, the velocity of the first ball is 8.5 divided by 3. It would travel at 2.83 meters a second. That's the laws of momentum. Laws of momentum must equal out. Because this is a positive, it must be towards the right. If it was a negative, it'd be the opposite way, to the left.